content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. And tonight we have a special guest in the studio, Brandon Roberts of Apex Electric. Tonight's discussion, we will focus on the roles of the various electrical professionals, approvals, installations, and inspections of electrical systems. Together, we will examine how each professional contributes a vital piece to the overall process and why a system of checks and balances is essential to achieving safe, reliable, and code compliant electrical installation. We will explore the responsibilities and the authorities of key industry professionals, including electrical engineers, master electricians, electrical contractors, plan review, project managers, electrical inspectors, and the authority having jurisdiction. We will discuss how these professionals work together throughout the life cycle of a project, from the initial design and permitting through installation, inspections, internalization, and occupancies. In addition, we will examine the importance of independent review and oversight, and why no single individual should serve as the sole authority responsible for every aspect of electrical installation. The electrical industry relies upon multiple layers of professional expertise to identify potential hazards, verify compliance, and ensure that electrical systems are installed in a manner that protects people, property, and critical infrastructure. We will also discuss the responsibilities, authorities, and potential liabilities associated with significant violations of the National Electrical Code, local ordinance, adopted building codes, fire codes, and manufacturers' installation requirements, and other applicable standards frequently encountered during the inspection process. Some of the questions we will address include: who is legally responsible for electrical designs? What authority does the plan reviewer have during the permit process? What responsibility does the electrical inspector have once a permit has been issued? Can an inspector redesign a system in the field? Who bears responsibility when a serious code violation is discovered? What happens when approved plans conflict with field conditions? What liabilities may arise when electrical work is performed without permits or inspections? How do contractors, engineers, inspectors, and building officials resolve disagreements regarding code interpretations? Why are documents, communication, and professional accountabilities critical to project success? Now, let's welcome Brandon Roberts from Apex Electric and begin our discussion. Brandon, welcome to Ask the Lady Electrical podcast. We appreciate you joining us this evening.
Um, Listen, Tabitha, first thing I want to tell you is thank you very much for having me on this. This has been what you don't know. This kind of been a dream of mine is to be a part of a podcast. And so it's just so awesome. And I'm honored that you've had me on here. Um, but so thank you very much for that.
Okay. Before we dive into our discussion about the many electrical professions involved in the design, constructions, installation, and inspections of electrical systems, I would like our listeners to get to know you a little bit better. Can you tell us a little about yourself? Specifically, how did you get started in the electrical industry? What inspired you to pursue this career path? And what has your journey looked like from your early days in the trade to where you are today? I would also love for you to share some of the key experiences, mentors, or opportunities that help shape your career, as well as the work you are doing with Apex Electric. What areas of electrical industries have you focused on, and what aspects of the professions do you enjoy the most? Finally, for those who may not be considering Finally, for those who may be considering a career in the electrical field, what advice would you give to them based on your own experience? Brandon, the floor is yours.
Tabitha, thank you very much for the intro. Thank you very much for having me as a guest on this podcast. This is great. This has kind of been a dream of mine to be a part of something like this. So it's an honor, and I really do appreciate you allowing me and giving me the opportunity to come and chat with you for a little while. I guess what got me started was I've been doing residential stuff for since I was probably 18 years old. My brother and I had a mortgage company when we were young, really young. And in 2008, 2009-ish, I'm sure you remember that time is when the market crashed and all these subprime loans started to default. And so we kind of had to reinvent ourselves. And so we did. And so we started like kind of flipping homes, right? So we were buying and selling them wholesale and stuff like that. In the midst of doing all that, I also love to work with my hands. And so I would end up doing a lot of the work. Well, no matter what it was whether it was flooring or like laying tile or drywall or whatever it was. And during the course of a lot of that stuff, I started to get more and more familiar with electrical work. One of the guys, so my brother's business partner, her husband, he's actually now the master that works for me at my business. But at the time, we were just kind of friends, and so he was kind of showing me, and I was kind of working alongside of him, and it really kind of piqued my interest, and it was something I was pretty good at, and it was something I enjoyed doing, and so it kind of just ballooned from there. And flipping houses is kind of feast or famine. And it's really, really good when it's really good, but when it's not, it can be terrible. And so I, I really wanted something more. I don't know, more structured, more certainty, right? I knew something was going to happen at the end of every week or at the end of every month, and I didn't get that flipping houses always. So that's kind of what directed me into the electrical trades. And the reason I picked the trades obviously is because I had some kind of some general interest there. Um, what happened though, as far as me starting Apex was, I think I'm truly a entrepreneur at heart, and I love business, and I really love helping people. I love relationships. All of those things. And being a business owner, I get to really operate on that level, and I get to not only do the electrical side of it, which I do enjoy, but I also get to run and operate a business, right? And I also get to have employees that I get to manage or take care of, right? And then those employees have a life that that I can kind of help them build, and so that's kind of why I created Apex. Apex has not been around for a very long time. But it's starting to grow. It's starting to grow pretty fast. Getting a lot of different things in place with the marketing, and of course referrals and stuff like that are growing, and so it's really turning into be something really, really cool. Um, and so, but with that, I tend to kind of focus more on the residential side,
Mhm.
and probably just because I feel like that's more my wheelhouse, that's more my expertise. Um, and it's what I like to do more. I have some commercial experience, but not very much, right? And so I kind of just want to stay in my lane. But the guy that works for me, the guy that has the masters with Apex, his background is commercial. So we can service all types of customers and clients because of that. But but like I said, my wheelhouse is much more residential, I would say, than anything else. And that's just kind of the lane that I kind of like to stay in, to be quite honest with you, service calls and those sorts of different things even too. Let me see this question of yours. I want to answer this question. Your last question was something to the effect of, what advice would you give to someone wants to consider this career path or something like that?
Yes.
This is important because I see so many young guys, and being in the trades, I see I'm with a lot of young guys. I've got an apprentice under me right now who's just an amazing young guy, and so this part is important to me. I would say, if you're considering a career path like in this specific trade, the first thing I would do probably is do a little bit of research on it, right? Make sure that you feel like this is something that you do, right? I mean, now everybody's using AI. I would ask AI, right? Like ask AI some questions like, what should I expect with this career path? What can I expect to make? What kind of benefits come with it, right? All the important things that you're going to want to know before you jump headlong into something like this. Like how much school time is it going to take? What's my income when I get out of school, and then what's it look like 10 years after I get out of school, and you know what I mean? And then think about those things, process those things. But if you get those answers and that is something you want to pursue, then I would jump in with both feet, and I would go to school and I would do all of those important things, right? I haven't spent a lot of time in like an electrical type of schooling. I learned the old fashioned way, but I will tell you, it is a part. It is a part of me that suffers a little bit because I didn't go the traditional route, and I wish now I wish I would have, and so that is an encouragement that I always give all these guys, especially the apprentice that works for me now. It's exactly what I tell them, man. Go to school, go to school because you can help me a little bit.
That is great advice.
It is great advice. Yeah. So go to school, focus on your schooling, get trained up, right? Become an expert in your field, and then perform. Go out and perform, and do what you love. I will tell you, it is a very rewarding field, and I will say this kind of lastly: this field, not only is it can provide you a successful lifestyle, and it can, you can have a family and do all those things that you want to do, but it's also not going anywhere. And not only is it not going anywhere, like you can see the trends and it's trending upward, especially I mentioned AI a minute ago. Because of AI and because of the energy demands for AI, not just the plants and stuff that they're building, but to actually power the AI systems, it's not going anywhere. Electricity is the energy source that powers all of this stuff. So, it's not going anywhere. This is a career for, it's like nursing, right? They're always going to need nurses. They're always going to need electricians. And I promise you, this field is in desperate need of good, skilled electricians. So, anyway, that's my piece, Tabitha. I hope that was a fairly good introduction. And like I said, I appreciate the time here with you this afternoon.
Absolutely. Thank you for that, Brandon.
You're welcome.
By the end of tonight's episode, our goal is to provide listeners with a clearer understanding of how the electrical professions function as a collaborative team effort and why every participant plays a critical role in protecting public safety. Whether you are an electrician, an engineer, inspector, property, or business owner, this conversation will provide valuable insight into the complex process that transform from electrical design from a set of plans into a safe, functional, and code compliant installation. One of the most common misconceptions in the construction industry is that a single individual designs an electrical system and others simply installs it. In reality, Successful electrical projects requires the coordination efforts of numerous professionals, each with distinguished responsibilities, qualifications, and legal obligations. Whether the project involves a commercial office building, manufacturing facility, hospital, school, data center, apartment complex, or industrial plant, every member of the project team contributes to ensuring that the electrical system is safe, reliable, code compliant, and capable of serving the needs of the occupants and the facility. This evening, we will explore the responsibilities of the follow. This evening, we will explore the responsibilities and interactions of the following professionals: the electrical engineer, the electrical designer, the registered design professional, the master electrician, electrical contractor, journeyman electrician, plan review, electrical inspector, authority having jurisdiction. We will discuss who is responsible for what, where their authority begins and ends, how we work together throughout a project, and what happens when a major code violations are discovered. Understanding these roles is essential not only for electrical professions, but also for everyone involved in the construction process. When each member of the team understands their responsibility and respects the responsibilities of others, the projects move more efficiently. Safely improves, Safety improves, and costly delays can often be avoided.
Mhm.
Join us as we take an in depth look at the professions who help bring the electrical systems from concept to completion and ensure that those systems serve the public safely for years to come. Phase 1: Project Planning. Every project begins with an ideal. A business owner may want to build a warehouse. A developer may want to construct an apartment complex. A manufacturer may need a new product facility. Before any electrical drawings are created, projects requirements must be identified. Some questions may include: what will the building be used for? How much power will be required? What type of equipment will be installed? What future expansion is anticipated? What code requirements applies? This information becomes the foundation of electrical design. The owner. The owner is an individual or organization funding the project. The owner responsibilities include establishing project goals, determining budget constraints, identifying operational needs, hiring qualified professionals. The owner is not responsible for designing the electrical system, but provides the information necessary for the design team to develop appropriate solution. The electrical system design. This phase is where the technical work begins. Question: who is legally responsible for the electrical design? The electrical engineer. The role of an electrical engineer. An electrical engineer is a highly trained professional responsible for the design, analyze, and oversight of electrical systems and equipment. Electrical engineers play specific Electrical engineers apply scientific principles, mathematics, and electrical engineering judgments to develop safe, reliable, and efficient electrical systems for residential, commercial, industrial, utility, and infrastructure projects. On many commercial and industrial projects, the electrical engineer serves as the engineer of records, assuming professional responsibility for design and performance of the electrical systems incorporated into the project. The key responsibilities are some include electrical load calculation, service sizing, feeder sizing, voltage drop analysis, short circuit calculations, arc fault studies, equipment selection, power distribution design, grounding and bonding designs, emergency system design. The engineers determines the size, the service size, transformer size, generator requirements, panel configuration, distribution equipment ratings. The engineer must design systems that comply with the National Electrical Code, energy codes, building codes, fire codes, and local amendments. Professional responsibilities and the liabilities. One of the most significant distinctions between the electrical engineer and other electrical professions is professional liability. When a licensed professional engineer steals engineering drawings, they are certifying that the design meets applicable engineering standards and code requirements. If a design defect contributes to property damage, equipment failure, serious injuries, or loss of life, the electrical engineer may face professional discipline, civil liability, and, in extreme cases, legal actions. This is an excellent real world example of how a design can be technically this is an excellent real world example of how a design can be technically constructible on paper, but still fails to meet the safety intent of the National Electrical Code. Here is an engineer design deficiency. The electrical room measured only 8 feet by 8 feet and contained one 3,000 amp 277 480 volt three phase service, one 1,200 amp 12208 volt three phase service. The equipment was arranged directly opposite of each other, creating several compliance issues. The first thing was the working clearance under the National Electrical Code 2020, Article 110.26A1, working space depth is determined by the voltage and the conditions of exposed energized parts. Because the exposed energized parts existed on both sides of the working space, the installation fell into a higher clearance condition, requiring substantial working depth. The room dimensions made it difficult or impossible to maintain compliant working clearance simultaneously for both services. In addition, the manufacturer's installation instructions required rear ventilation clearance, creating another conflict under National Electrical Code Article 110.3b, which requires equipment to be installed in accordance with its listing and labeling instructions.
Mm-hmm.
Second means of egress violation. National Electrical Code Article 110.26C2B requires a second entrance to egress from working space where equipment is rated 1,200 amps or more, over 6 feet wide, and contains overcurrent devices, switching devices, or control devices. The 3,000 amp service clearly triggered the second egress requirement. The engineer proposed solution. The engineer recognized that the room configuration left no practical space for a conventional stairway because the electrical room, the engineer recognized that the room configuration left no practical space for a conventional stairway because the electrical room floor was 24 inches lower than the adjacent room. Installing stairs would intrude into required working space. The room footprint could not be enlarged. The proposal was to cut an opening into the adjacent mechanical room, install a permanently mounted ladder, provide handrails and grab bars, use the ladder as the second means of egress. From a purely practical standpoint, the proposal appears reasonable. However, it did not satisfy the National Electrical Code, the authority having jurisdiction interpretation. The authority having jurisdiction rejected the latter because it did not meet the intent of the National Electrical Code, Article 110.26c. The authority having jurisdiction correctly focused on the emergency scenario that the egress requirement is intended to address. An electrician exposed to an arc flash event may experience burns to the hands, burns to the face, impaired vision, reduced mobility, disorientation. Using a climb ladder, you would need to use both hands. You would need to be balanced. You would need coordination and physical climbing abilities. The authority having jurisdiction compared this concept to the National Electrical Code requirements for panic hardware on personal doors serving qualifying electrical rooms. The code recognized that an injured worker may be unable to grasp or manipulate conventional door hardware. If a person may not be able to safely operate a door knob after an electrical accident, it follows that they may also be unable to climb a ladder. Therefore, the ladder failed to provide a code compliant means of egress. The final corrective action that was accepted by the authority having jurisdiction saw cutting through a 4-inch concrete wall, creating a second exit opening, constructing permanent steps that comply with the applicable building requirements, maintaining the required electrical working space. This solution was significantly more expensive, but satisfied the minimum safety intents of the National Electrical Code, Article 110.26c. The lessons learned. This project highlights 3 common design problems that inspectors frequently encounter. The electrical room size is often underestimated. Developers frequently attempt to minimize electrical room footprints because the electrical rooms do not generate revenue. As construction costs rise, pressure increases to allocate spaces to retail areas, office spaces, and apartment buildings. Unfortunately, electrical equipment still requires safe access and maintenance space. NEC clearances are minimum, not design targets. Many designers attempt to fit equipment into rooms using only minimum dimensions permitted by the National Electrical Code, Article 110.26. This often leaves no room for future maintenance, equipment replacement, ventilation requirements, seismic bracing, additional raceways, emergency egress. A room designed exactly to the minimum clearance requirements frequently becomes non-compliant once real-world installation conditions are considered. Early coordination prevents expensive corrections. Had the electrical engineer, architect, or the plan reviewer and authority having jurisdiction coordinated earlier in the design process, the deficiency likely would have been discovered before construction. Instead, the project incurred additional engineering costs, demolition costs, concrete cutting costs, schedule delays, inspection delays. So the key takeaways: the National Electrical Code working space and egress equipments are not merely dimensional requirements, they are life safety provisions. Electrical room may appear functional during normal operations, but if a qualified worker cannot safely escape following an arc fault or electrical fault event, the installation fails to meet the fundamental intents of the National Electrical Code, Article 110.26. This case demonstrates why electrical room designs must consider not only equipment fits and construction costs, but also emergency workers' safety, maintainability, manufacturers' requirements, and long-term code compliance. Seismic design considerations in the electrical service. Before we go there, Brandon, do you have anything you would like to add or anything that you have to say?
No, this is great. Honestly, Tabitha, to be honest with you, this is a lot of information, a lot of great information. Um, as you're going through here, I'm thinking about uh, all the different scenarios. You know, what I mean, all the different things that's happened over the course of my tenure being an electrician. Um, all the different scenarios, right? And we were kind of talking earlier before we started about how specifically how the engineer they have this idea in mind, right, and the plans are drawn, right, and then the plans get sent to the project manager, down the line, down the line, and then it ends up in my hands, right. And then let's just say I'm in a house, and that these plans end up in my hands, and we're sitting there, and I'm looking at the plans, and I'm looking at the physical structure of the house, and I'm thinking, oh, there's no way that this receptacle, as basic as it gets, right? There's no way that this receptacle can go there, or there needs to be a receptacle here, or you have a light switch here, but obviously there can't be a light switch here because the overframing of the door or whatever else.
Or behind
Um,
the door, because I have
or
a
behind, that's exactly right,
door.
or behind the door, or they had the door swinging in, left-handed door, but like you said, then the switch is behind. So there's so many scenarios, right, where this happens. I think for a lot of people, at least in my shoes, and I speak for in my shoes, is we get these plans, and then you just automatically think that because someone with a certain degree drew these plans out, that they're going to be perfect. Well, they're rarely ever perfect, at least in my experience. They're rarely ever perfect, and how can they be, right? You can't never plan for every little single thing, right? You can't always plan for every little corner or nook or whatever. And sometimes things just don't lay out that way. And so kind of to your point, that's kind of the chain of command, right? And so, but everybody kind of needs to be the expert in their particular field, because there are judgment calls that need to happen, out in the field. And if I'm a really good electrician and someone who knows, let's say, the NEC inside and out, and knows some of these parameters that I have to work it within, and has a good relationship with either the homeowner or the engineer or someone like that, then I can make a lot of those judgment calls myself, and or reach out to, like we were talking earlier, reach out to the inspector, right? And
Yeah.
say, hey, Tabitha, can I do this? Can I make this call? Can this go here or whatever? Or up the chain. And so as you're reading through this, and discussing these different topics, that's kind of the thing that comes to my mind. One of the things that I wanted to kind of touch on is, yeah, another reason why you should go to school, right, is so that you do know what you're doing. And if the plans don't obviously spell it out, then you can make those informed decisions and not be scared to make those decisions.
Absolutely. Thank you for your input.
You're welcome.
Equipment, seismic design considerations in electrical services. Equipment installation. Seismic design is a critical component of electrical system design, particularly for large service equipment installations. In a recent project, seismic compliance became a significant issue during the plan review and approval process. The authority having jurisdiction noted that no project specific seismic design documentations had been submitted, while the equipment manufacturer provided the standard seismic anchor information. The authority having jurisdiction determined that the manufacturer's literature alone was insignificant to demonstrate compliance with the applicable building and seismic design requirements. The authority having jurisdiction acknowledged the manufacturer's reference safety factor of 1.5, but the emphasis that the actual seismic design requirements must be determined by a qualified structural engineer. These calculations must be based on the project site specific conditions, including the site class, the seismic design category, equipment location, and supporting structural elements. Additionally, the design must address the mounting hardware, the anchor method, and restraint systems, and any required sway bracing necessary to ensure the equipment remains secure during a seismic event. The manufacturer's documentation itself states that its anchorage recommendations are only one component of the overall seismic design, process, and are not intended to replace project specific engineering calculations and details. As part as part of the review process, the authority having jurisdiction requested that the engineer provide seismic restraint specifications for each service assembly, detailed drawings showing that the anchorage bolt pattern, the type, the grade, diameter, and embedment length of all anchored bolts, the equipment centered on gravity, any required top bracing, lateral bracing, or sway bracing necessary to satisfy the seismic design requirements for the installation location. The authority having jurisdiction further notes that the manufacturer provided bolt patterns are intended primarily for the equipment attachment and may not adequately address project specific seismic forces. Consequently, the design professional is responsible for determining and documenting the anchorage and restraint requirements necessary to comply with the governing building and seismic code. The, the purpose The purpose of the authority having jurisdiction request is not to redesign the installation, but rather to verify that a complete seismic design has been performed and that the installation will conform to the approved engineered design. In response, the engineer submitted additional documentation, including fault carrying information, manufacturer switchboard clearance requirements, and manufactured seismic information. The, adequ- the adequacy of this response depends on whether the submittal documents include project specifics, engineering calculations, seal seismic details, anchorage designs, and restraints specifications that address the authority having jurisdiction original concerns. This situation highlights the importance of coordination between the electrical engineer, structural engineer, equipment manufacturers, contractors, plan review, and electrical inspectors. Each professional plays a critical role in ensuring that the electrical equipment is not only operational and code compliant, but also capable of remaining safely secured during a seismic event. Why the electrical engineer is important. The electrical engineer serves as the technical authority for electrical design. Their work established the foundation for permitting construction, inspections, and long term operations of the electrical system. A well engineered design improves safety, reliability, efficiency, maintainability, and code compliance, where reducing costly construction errors and future system failures. How electrical engineers work with the project team. The electrical engineer collaborates with numerous professionals throughout a project's life cycle. The electrical designer develops detailed drawings and layouts under the engineering direction. Architect coordinates buildings use and space requirements. The planner review. The planner review reviews steel plans for code compliance before permits are issued. The master electrician and electrical contractors install the systems accordingly to the approved plans. Electrical inspectors verify the installation complies with the National Electrical Code, approves plans, and local regulations. Next, we have the electrical designer. An electrical designer often works under the supervision of an engineer. An electrical designer plays a critical role in transforming the electrical requirements of a building or facility into detailed construction documents that can be used for permitting, installation, and inspections. Working under the direction of an electrical engineer independently where permitted by law. The electrical designer develops the practical layout and the design of the electrical system for residential, commercial, and industrial projects. Some responsibilities may include drafting plans, creating plan schedules, panel schedules, developing lighting layouts, receptacle layouts, equipment layouts. The designer converts engineering concepts into detailed construction documents. How the electrical designer fits into the project team. The electrical designer serves as the link between the project concept developed by the architect and engineer and the actual installation performed by the electrical contractor. Their work is reviewed by the electrical engineer when required, examined by the planner reviewer, installed by the electricians, and ultimately verified by the electrical inspector. A well designed electrical system helps improve safety, reduce construction costs, increase energy efficiency, minimize installation conflicts, facilitate successful inspections, ensure long term reliability of electrical systems. Because of this, the electrical designer is one of the most important contributors to a successful construction project, providing the foundation upon which engineers, contractors, plan reviewers, and inspectors build and evaluate electrical installations. Registered design professionals. The registered design professional may be a professional engineer, an architect. The registered design professional coordinates building systems, including structural, mechanical, plumbing, fire protection, electrical. Their responsibilities is ensuring all systems work together without conflict. Coordination between the disciplines. The electrical systems cannot be designed independently. Electrical professionals must coordinate with mechanical engineers regarding HVAC loads, architects regarding building layouts, structural engineers regarding equipment support, fire protection engineers regarding life safety system. Communication is essential. A design completed in isolation often leads to a costly field change. What authority does the plan reviewer have during the permit process? Before construction begins, plans are submitted for review. The planner reviewer. The plan reviewer performs a detailed examination of construction documents. The responsibilities include reviewing code compliance, reviewing load calculation, verifying equipment ratings, evaluating grounding methods, reviewing emergency systems, identifying design conflicts. Plan reviewers serve as the first line of defense against code violation. They often identify issues before construction begins. This saves both time and money. Why plan review matters. Correcting a mistake on paper is inexpensive. Correcting the same mistake after the installation costs thousands of dollars.
Yep.
A thorough plan review protects owners, contractor, occupancies, and the inspectors. Most importantly, it protects public safety. This next scenario is a realistic example of how construction, design, plan review, and inspections can collide late in the project. The VTAC, Vertical Terminal Air Conditioning Units, which are compact HVAC systems installed in hotel room closets, have raised concerns regarding accessibility for servicing. The installation instructions and the owner manual details the closet size and various access doors locations. The authority having jurisdiction has identified a significant issue. The current setup does not allow for adequate access to the inside of the unit for servicing. The electrical contractor and plan review involve using 1900 boxes located to the left of the unit as a disconnect switch. This switch was intended to disconnect power to the unit, allowing for the removal during a service or replacement. However, the authority having jurisdiction has mandated that the unit must be serviceable in place, citing that it is permanently attached to the building structure. The authority having jurisdiction reference Article 110.26A2, which states that the width of the working space in front of the electrical equipment must be either the width of the equipment or 30 inches, whichever is greater. Additionally, the workspace must allow for at least a 90-degree opening of equipment doors or hinge panels. As it stands, cannot the authority having jurisdiction cannot approve the current clearance for the VTAC units installation. The authority having jurisdiction response. From a code enforcement perspective, the issue is not necessarily whether the VTAC units can be removed from the closet. The authority having jurisdiction concern is whether the electrical components requiring examination, adjustments, and servicing or maintenance can be safely accessed while the equipment remains installed. The core disagreement between the electrical contractor, the project team, the disagreement, the rebuttal. The VTAC manufacturer designed these units to slide out for service. The disconnecting means is provided through the adjacent switch box. Power can be disconnected and the unit can be removed from the closet for maintenance. The installation was submitted and approved during planning review. Similar installations exist in all 130 rooms. The authority having jurisdiction position. The unit is permanently attached to the building. Access to the electrical wiring and electrical components is restricted by the closet's dimensions. Article 110.26A2 requires significant working space width where servicing of energized electrical equipment may be necessary. Access panels or service openings may be required. Plan approval does not relieve the designer or the contractor from the minimum National Electrical Code compliance. Important NEC question. The first question that must be addressed is Article 110.26 actually does apply to this equipment. And it states that the equipment likely required examination, adjustment, servicing, and maintaining while energized. The project team argued the VTAC is not intended to be serviced while energized. The disconnect switch de-energizes the unit before service. The manufacturer's instructions requires the removal of the unit before internal servicing. Therefore, Article 110.26 working clearance may not apply or be applicable to the interior of the VTAC unit. The authority having jurisdiction countered. The access is required to the electrical wiring compartments. The disconnect itself requires working clearance. Access doors and closet dimensions prevent proper access to the electrical components. Future maintenance personnel must be able to safely access the equipment under Article 110.3b. The manufacturer's instruction listed and labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. If the manufacturer's installation instructions clearly states service is accomplished by removing the chassis, internal components are not intended to be serviced in place, the minimum closet dimensions shown are acceptable, then these instructions become an important part of the discussion. Per manufacturer's instruction, The project team now must provide the authority having jurisdiction with the manufacturer's instruction manual, the service manual, listing documentations, closet dimension requirements, written statements from the manufacturers if available. Now, the planner review approval issue. The project management team is correct that the electrical plans were reviewed. The mechanical plans were reviewed. Permits were issued. However, approval during planning review generally does not eliminate the authority having jurisdiction to require corrections later if a code violation is discovered. Most jurisdictions have language similar to approval of plans shall not be construed as permitting any violations of applicable codes. Therefore, while the approved plans help demonstrate good faith reliance on the review process, they do not automatically resolve the code issue. Now we have to come together to have a collaborative solution, a resolution. So the resolution, rather than debating who is responsible, the best approach is a technical resolution. The authority having jurisdiction focus on three questions. Is Article 110.26 applicable? The engineer of record should provide a written code analyst addressing whether the VTAP equipment falls under 110.26 working clearance requirements. Question 2, does the manufacturer requires in-place servicing? The manufacturer must clarify whether the internal service is accepted while installed, whether removal of the chassis is the intended service method, whether the closet dimensions must meet the listing requirements. Question 3, is additional access panels required? The possible solutions may include access panels, larger access doors, removable closet framings, alternative disconnect locations, and field modifications approved by the engineer and the manufacturer. At the same time, the authority having jurisdictions concerns about the future access to wiring compartments and electrical servicing is reasonable and deserves a documented engineering evaluation. The most effective path forward is a joint code review meeting focused on the manufacturer listing requirements, Article 110.3b and Article 110.20c applicability, and the actual service procedures for the VTAP units. This shifts the discussion from who missed it to what installation ultimately satisfy both the listing and the National Electrical Code. Phase 4 is the construction. Once permits are issued, construction begins. The project manager coordinates the entire project. Responsibility includes scheduling, budget management, coordination among the trades, communication with the stockholders, monitoring project progress, and the project manager serves as a bridge between the owners, the design professionals, contractors, and inspectors. Brandon, as the owner of Apex Electric, please share with our listeners some of the roles and responsibilities within your company.
Wow, the all of them, right? All the roles, um, not just in the field, the day to day processes, but everything that the business entails, right? um, but in terms of my role specifically in the field, and as it relates to kind of the things that you've been talking about here, um, is can you still hear me?
Yes.
Yes, you can. And as it relates to what we've been talking about here, and I kind of mentioned it earlier, and that is my role as me being supposed to be the expert in the field, right? Like I don't, I don't just show up. Let's say I'm wiring a house based off of plans. I don't just show up and wire the house exactly how the plans are laid out. I mean, I do that, right? It does inform me as to what the owner or the project manager or whoever, the engineer, whoever, designed them and laid those out. It does inform me as to what they want and how they want it to look. But it is my responsibility as the journeyman, as the master of this company putting out a product. It is my responsibility to ensure that this product that I'm putting out, that wiring this house and everything that entails, that it's up to par and it's up to code, and that is my responsibility. And so within Apex, those things fall on my shoulders. Well, they fall on my shoulders and the master that holds the license at Apex, but those things fall on our shoulders. And those are things that I preach to my employees and my other journeymen and of course my apprentices, that those things are important, and those things will help ensure that, like in your scenario with 130 rooms in that hotel, I can't imagine that mistake, right? And that mistake could have been avoided had there have been a little bit more communication on the front end of that project, right? It wouldn't have been a situation where the inspector or the AHJ comes in and says, you guys missed this. And not only did you miss it here, you missed it on 129 other rooms, and so that's very important. Again, like we talked about earlier, part of my responsibility, yes, is being an expert. But I think the other part is having an open line of communication where if I don't know the answer, and I don't know exactly where something's supposed to go or how it's supposed to be or what it's supposed to look like, that those lines of communication are open, and that I'm not afraid to reach out to someone that knows, right? The inspector or whoever else, project manager, program reviewer, all those people that I can reach out to and clear those, that miscommunication up.
Thank you, Brandon.
You're
One
welcome.
point that stands out from your experience is that the electrical construction is rarely a straight line from design to completion. Even with the best plans, projects encounter unforeseen conditions involving code interpretation, manufacturer's requirement, utility constraints, and coordination challenging among the trades. This is precisely why the electrical industry relies on multiple layers of review and oversight. No single professional possesses all of the information necessary to guarantee safe installation. Engineers, designers, contractors, electricians, plan review, inspectors, and the authority having jurisdiction each contributes a unique perspective that helps identify potential hazards before they become serious safety issues. Once construction is underway, the next critical step is verification. This is where inspections play an essential role in confirming that the installation complies with the adopted codes, approved plans, and applicable safety standards. The inspections. Inspections occur throughout the construction process. The electrical inspector represents the authority having jurisdictions. Responsibilities include verifying code compliance, reviewing installations, identifying violations, ensuring public safety, approving compliant work. The inspector does not design the system. The inspector does not perform installations. The inspector evaluates the work against adopted codes and approved plans. Common misconceptions about the inspectors are often misunderstood. An inspector is not an adversary. An inspector's responsibility is public safety. The best inspections occur when contractors and inspectors communicate
That's right.
professionally and respectfully. Both parties have the same goal, a safe and code compliant installation. The authority having jurisdiction is the organization responsible for enforcing adopted codes. Examples include government, multiple municipal governments, county governments, state agencies. The authority having jurisdictions established the inspection requirements, the permits requirements, local code interpretations. The authority having jurisdiction has the final authority regarding code enforcement. Working together as a team. A successful project requires teamwork. Consider the process. The owner defines the project needs. The engineer designs the system. The designer prepares construction documents. The plan review evaluates the plan. The contractors build the system. The master electrician supervises the installation. The journeyman electrician performs the work, and the utility provides the service. The inspector verifies the compliance, and the authority having jurisdiction enforces adopted codes. Each professional depends on the other. Each profession depends on the others. When communication breaks down, projects suffer. When communication succeeds, projects thrive. The
Mm-hmm.
lessons from electrical profession: respect the expertise of other professionals. Ask questions early. Document decisions. Follow approved plans. Communicate concerns immediately. Never assume. Always verify. Remember that every profession contributes to the safety and success of the project. In conclusion, electrical safety is not achieved by one individual. It is achieved when qualified personnel work together, communicate effectively, respect each other's expertise, and remain committed to protecting the public. Brandon, do you have any final thoughts?
I don't. Other than again, thank you very much for for asking me to come be a guest on this podcast. This particular episode was great. This was a lot of information, and a lot of good information. And I'm glad I was a part of this one in particular. Like we talked about even before we started, it is so important that communication stays in place and that communication doesn't break down. And I will just tell you, just from experience, that. Um, I have been in situations where I wasn't as proactive as I should have been on some of those communications. And it cost me a ton of time. It cost me a lot of money, but probably more importantly than all of that, it costed the homeowner time and the homeowner money. And that's a problem, a huge problem. And so that's probably my biggest takeaway out of this episode altogether, Tabitha, is just the importance of, like you said, teamwork and working together, and making sure that communication doesn't break down, and ask questions, right? Be informed, ask questions, and make sure you don't make mistakes, and cut it off at the pass, and take advantage of it early instead of when it's too late. So again, thank you so much for this, Tabitha. I hope I can join you again sometime in the future. And yeah, thank you. God bless.
Thank you, Brandon, for joining us for this episode of Ask the Lady Electrical Inspector podcast. Please join me Wednesday on June the 17th, 2026 for another episode. I am eager to feature more industry guests to explore innovative products within the electrical industry. I invite any electrical industry organization interested in showcasing their services and products to contact me. Together, we can contribute to educating the public and sharing knowledge to identify and address electrical safety concerns. Feel free to reach out to me via social media on if you have any questions, comments, or topic suggestions. I am available on Facebook, Instagram, and YouTube under the name Ask the Lady Electrical Inspector. Also, you can email me, Ask the Lady Electrical Inspector at gmail.com for further discussions or to share your thoughts. Let us collaborate to maintain safe and compliant electrical systems. Until next time, stay safe, stay informed, and remember that electrical safety begins long before the first wire is installed. It begins with teamwork, communication, and commitment to doing the job right. Thank you for your time. Good night.